So for this recording, we're going to talk about standard form. And standard form, unfortunately, is one of those forms of a line that doesn't really tell you that much when you're just glancing at the equation. We have slope-intercept form. That tells you the slope. It tells you the y-intercept just from glancing at it. You have point-slope form, which tells you a point on the line. It also tells you the slope of the line. But standard form is a little bit different. Standard form is ax plus by equals c. Okay, and A, B, and C are all going to be numbers, and the X and the Y are going to be the only variables left in your equation. For example, if I had something like 2X plus 9Y equals 36. The 2, the 9, the 36, none of those really tell me anything about the graph, but I can use it to find out things about this particular graph. So maybe we want to figure out how to graph it, like example 1. Graph 14x minus 8y equals 56. A lot of people, their gut reaction is change it into a different form. We're not as comfortable with standard form, so we typically want to try to get it to slope-intercept form. But I actually think there's an easier way, okay? And I would add this into your Flipbook. I suggest using intercepts, okay? So we want to graph with intercepts. So what are intercepts? Well, I want you to think about your x and y axes, okay? I'm going to start a new page here, but if I look at my two axes, here's my y-axis, here's my x-axis. If I were to plot a point, let me change the color so you can see what the line is here. Let's say, or let's plot a line, an entire line there. No matter what, anytime that you graph a line, unless the domain is restricted somehow, it's going to cross the x-axis and the y-axis, okay? So this point here is what we call the x-intercept because that's where it's crossing the x-axis, and this point here is what we would call the y-intercept because it's crossing the y-axis. Now, I didn't label anything on these axes, so the only thing that I know about each of them is one of the coordinates of each. For example here, this x-coordinate, I don't really know what it is for the x-intercept, but I do know that the y-coordinate has to be 0, right? So for any x-intercept, no matter if it was over here or over here, anywhere on this x-axis, the y-coordinate would be 0. For the y-intercept, the only thing I know about this point is that the x-coordinate is 0, right? So anytime I'm trying to find intercepts, I can follow a rule. If I'm trying to find the x-intercept, and I would recommend maybe writing this down somewhere in your Flipbook, to find the x-intercept, like we said, any x-intercept has a y-coordinate of 0. So to find it, you are going to plug in 0 for y. Okay, so that's to find your x-intercept. To find your y-intercept, you're going to do the opposite. You're going to plug in 0 for x. Okay, and again, that's because for a y-intercept, to intersect that y-axis, you would have a 0 as your x-coordinate. So to find the x-intercept, plug in 0 for y. To find the y-intercept, plug in 0 for x. So let's look back at our example where we were asked to graph. So in order to graph it, we're going to find our two intercepts because any 2 points creates a line. So as long as we find the x-intercept and the y-intercept, that's 2 points, we have our line. So to find the x-intercept, remember we need to plug in 0 for y. So we're going to do 14x minus 8 times 0 equals 56. We plugged in 0 for y. The 8 times 0 is just 0. So subtracting 0, that's not going to change anything. This part is going to go away, and we'll just have 14x equals 56. Divide both sides by 14, so x equals 4. That means on our x-axis, our intercept is 1, 2, 3, 4. So it's over here. Okay. To find our y-intercept. The y-intercept, we're going to do the opposite. We're going to plug in 0 for x. So 14 times 0 minus 8y equals 56. The 14 times 0 goes away, and we only have negative 8y equals 56, which means y equals negative 7. That would be our y-intercept. So down here at 1, 2, 3, 4, 5, 6, at negative 7. 2 points, that's enough to make a line. So we can go ahead and connect those two with that straight line, you'd be using a ruler. I always suggest, again, putting arrows on the end just to say I know this continues forever in both directions. And you could, again, you could have changed it to slope-intercept form, but 2 points is all you need, and it's pretty simple to find both of those intercepts. The next thing is looking at a real world type problem, okay? It says, what equation would represent this situation? If you're earning money by washing cars and mowing lawns, you charge $20 per lawn and $15 per car. If you earn $325, what equation would represent this situation? So let's think about what we don't know. We don't know how many lawns, we don't know how many cars. So those are our two variables. And remember, only x and y should be the variables in our final equation. So that means x needs to be one of the unknowns and y should be the other. So if x is going to be, let's say, we're looking for the number of lawns, then that's how we'll define it. X is the number of lawns. So then y would have to be the number of cars. So if we're looking for an equation here, we would say, well, it's $20 per lawn, and let's say x is number of lawns, so we would have 20x, and you're earning $15 per car. So that's going to be 15y because y is the number of cars, and our total is supposed to be $325. Okay, now this next part is a little bit more challenging because it wants an example solution of the equation and tell what it means. Sometimes it works out really nicely that our intercepts could be solutions. So for example, maybe if I find the x-intercept, then that means that I'm plugging in 0 for y. That would mean 0 cars. But if I do that, I would have 20x plus 15 times 0 equals 325. So 20x would equal 325, and if I divide 325 by 20, I'm going to get that x equals 16.25. And that's not really going to make sense in this real world scenario. So you're not going to get paid for, mowing 16 and 1/4 lawns. So let's try to think of one that is going to work out a little bit better. And I think it works out the same way with the y-intercept. It's just not that pretty. So my suggestion would really be just kind of go through and do a little bit of guessing and checking, see what you come up with. Let's say maybe if I do, I don't know, let's say five lawns. If we do 5 lawns, well, I would plug in 5 for 20, and that's 100. So I would have 225 left over. And so the question would be, is 225 divisible by 15? And I believe it is. So like I said, if I think maybe x equals 5, if I plug that in, 20 times 5 plus 15y equals 325. So again, that's 100 plus 15y equals 325. Taking away 100, the 15y would equal 225. So then y would equal, well, 225 divided by 15 actually happens to be 15. So an example solution, this is not the only one, but an example solution would be that the point 515 is actually on that graph. And what this means is that you can earn the $325 by mowing 5 lawns and washing 15 cars. Again, this is not the only solution. It just happens to be one of them. You could go through and test other values to find something that you want in your flipbook, or obviously you're welcome to use this one as well.